There are discoveries in astronomy that bring comfort. Beautiful nebulae, the birth of stars, distant galaxies that remind us how vast and breathtaking the universe truly is. But then there are discoveries that do the opposite, that pierce through our sense of security and remind us that space is not just beautiful, it is unpredictable, hostile, and sometimes terrifying. And that is exactly what has just happened. The James Webb Space Telescope, humanity's most powerful eye on the cosmos, has detected something racing toward our solar system from the void beyond the helopore. This isn't an asteroid from our belt, nor a comet born in the frozen Oort cloud. No, this is an interstellar object, something that has traveled unfathomable distances through the dark, cold ocean between stars. And for the first time, Webb has captured its details with frightening clarity. Scientists are calling it 3E Atlas, and it is not only moving at breakneck speed, but also behaving in ways that no ordinary comet should. With its strange brightness, its massive scale, and its incomprehensible age, 3 Atlas is forcing scientists to question whether this is merely a frozen relic of another star system or something far more enigmatic. Tonight, we dive deep into what Webb has revealed about this object, why astronomers are both fascinated and unsettled, and what its arrival could mean for humanity. The story began quietly on July the 1st of this year, when the Atlas Survey Telescope in Rio Gerardo, Chile, was conducting its routine sweep of the skies. Designed to detect near-Earth objects, Atlas has captured thousands of asteroids before. But that night its instruments picked up something unusual, an object moving faster than anything typically seen, a faint speck streaking against the galactic plane. At first, it was cataloged as just another cometary candidate, but within hours, further analysis revealed something extraordinary. Its orbit was hyperbolic, meaning it did not originate from our solar system. This was no local wanderer, it was a traveler from the stars. As data poured in from other observatories around the globe, astronomers confirmed that this was only the third known interstellar object ever detected after Oumuamua in 2017 and Boris in 2019. They named DAT 3 Atlas. But this new visitor was unlike the others in a crucial way. Its speed traveling at 58 km, nearly twice as fast as Boris and far quicker than Oumuamua. It shattered expectations. It was as if this object had been hurled through space with a force far greater than anything we understood. And with each passing night, its trajectory made one thing clear. It was coming straight into the heart of our solar system. When Webb's instruments were finally trained on 3I, the results stunned astronomers. They had expected the grainy blur of a frozen rock surrounded by a coma of dust and ice. Instead, Webb captured something far brighter, larger, and more complex. The nucleus of 3 Atlas was estimated to be nearly 10 kilometers across, making it far larger than its predecessors. Surrounding it was a coma, a halo of dust and gas. But what unnerved scientists was its sheer brightness. It was the brightest interstellar object ever recorded, glowing with an intensity that suggested powerful activity within. And then came the details that shook confidence even further. Its rotation was unusually stable with a period of about 29 hours. But its brightness hardly changed, implying a smoother, more uniform surface than expected for a comet of this size, where Boris shed vast plumes of dust and gas. 3 Atlas seemed restrained, almost controlled, radiating just enough to maintain its halo while keeping its form intact. Its light curve revealed minimal variation, so consistent it felt artificial. And as Webb analyzed its spectrum, it found chemical signatures redder than even D-type asteroids, hinting at exotic origins unlike anything seen in our solar system. To astronomers used to the chaos of comets, this was too orderly, too deliberate. It raised a chilling question. Was this truly a natural object, or were we staring at something designed? If 3I Atlas is natural, then it is also ancient, almost impossibly so. Using its velocity as a clue, astronomers estimated that it could be between 3 and 11 billion years old. To put that into perspective, it might have formed before our sun even existed, a relic from a star system that has long since died. This staggering age means that 3I Atlas could be carrying materials from an era of the universe that no longer exists, matter shaped by processes alien to our current galaxy. But this only deepened the mystery. How could an object survive billions of years of interstellar travel without fragmenting or eroding? Cosmic radiation, impacts with micrometeoroids, and the sheer emptiness of deep space should have worn it down to nothing. Yet here it was, intact, massive, and bright. Some scientists speculated that its structure must be incredibly dense, made of exotic ices and materials hardened under unimaginable pressures. Others suggested it could be a fragment of a destroyed planet, ejected violently into space and set on a course that would eventually bring it here. But then came the theories. That unsettled everyone. What if its durability, its smoothness, its strange stability were not natural at all? What if it was built this way? A construct designed to survive billions of years, silently crossing star systems until it found us. Perhaps the most unnerving aspect of 3I Atlas is its path through the solar system. Calculations show it will reach its closest point to the Sun on October 30th, passing just inside the orbit of Mars before being flung back into interstellar space. But unlike other interstellar comets, its trajectory has raised eyebrows. Its orbit does not appear random. The way it threads through gravitational influences, the precision with which it bypasses Earth while still offering us a clear view, feels too exact. Some astronomers argue this is nothing more than celestial mechanics playing out on a grand scale. But others quietly admit that its course looks suspiciously like navigation, as if its approach was meant to be visible, meant to be studied, but never meant to collide. If that's true, then 3 Atlas isn't just a traveler. It's a messenger placed on a path to intersect with our gaze exactly when humanity had the technology to see it. The James Webb Telescope was designed to peer into the dawn of time. But, perhaps, just perhaps, it was destined to capture this object at this exact moment. And if that's the case, then the question becomes terrifyingly clear. Who sent it, and why? As Webb continued to monitor 3 Atlas, one of the most baffling discoveries came not from its visible light but from its energy profile. Natural comets and asteroids emit heat chaotically, releasing gases as the sun's radiation cracks their icy surfaces. But 3 Atlas did not behave this way. Instead, it seemed to regulate its heat output, releasing energy in rhythmic intervals, almost like a heartbeat. Infrared data showed that these pulses weren't random. They repeated in sequences that mirrored mathematical constants, including prime numbers and ratios consistent with Fibonacci sequences. To dismiss this as coincidence was possible at first, but as the data accumulated, the statistical probability became almost impossible to ignore. Was this simply a quirk of exotic chemistry? Or was this a signal deliberately encoded into the very way the object interacted with sunlight? For some astronomers, this was the tipping point. A natural comet does not communicate. And yet the patterns of 3I Atlas were beginning to look less like physics and more like intention. High-resolution imagery revealed more disturbing details about the structure of 3 Atlas. While most comets are irregular, jagged, and unpredictable in their spin, this object appeared unnervingly smooth and uniform. Its light curve, usually a chaotic flicker in natural bodies, remained consistent over long observations, suggesting a surface without significant variation. Even stranger, parts of it seemed angular with flat regions that reflected light in sharp bursts. Some observers described it as crystalline, others as metallic, but all agreed it lacked the randomness expected of something shaped purely by collisions and gravity. In certain angles, Webb even detected reflections that hinted at panel-like structures as though its outer shell was segmented. This resemblance to design rather than geology fueled speculation that 3 Atlas was not just a rock drifting through space, but perhaps a construct, something engineered to survive the brutal emptiness of the interstellar medium for billions of years. And if its shape was intentional, then its survival was not luck. It was by design. In the early days of discovery, updates about 3 Atlas flowed freely across the scientific community. Data from Webb ground-based observatories and space agencies circulated openly, and researchers across the globe collaborated to decode its mysteries. But as more evidence piled up suggesting that this object was anything but ordinary, that openness began to fade. Reports were suddenly delayed. Data streams went dark, and researchers who once gave interviews stopped answering questions. Leaks from within institutions hinted at classified briefings being held between governments, defense organizations, and space agencies. Some sources claimed that the object's unusual signals were too deliberate to be ignored, while others hinted at discussions about potential risks. What if 3I Atlas wasn't just a relic, but an active probe capable of observation or even more? Publicly, agencies reassured the world that everything was under control. But behind the curtain, urgency was rising.